Today we're looking at the properties of logs. There are three different properties we're going to look at: the multiplication property, division, and then exponents. So if you're given the log base b of x times y, that is equivalent to the log base b of x plus the log base b of y. So if inside your log you have multiplication, you can split that up into two separate problems. So the log base b of x times y, you can split up to the log base b of x plus the log base b of y. This is going to be helpful if you don't know what the value is for one part, but you can split it up into two different parts. It'll help you out. We'll get to those later. Division property is very similar. If we have log base b of x divided by y, that's going to be log base b of x minus log base b of y. So multiplication, they split apart into addition. Division splits apart into subtraction. And then if we have an exponent, that exponent is going to become a coefficient. So log base b of x to the r power will be r times log base b of x, or just r log base b of x. When it's written simplified like this, we call this condensed form. So if I want you to condense it, then you're going to take the addition or subtraction and put it into multiplication division. If I want you to expand it, you're going to go from this left-hand side, where you've got the multiplication, division, or exponent, and you're going to move it to the right-hand side. So we call that expanded. So if we look at a couple examples of this, first if I say to expand log base 3 of 2x. Here we have multiplication, so we can split that up. This will equal, it will expand to log base 3 of 2, because it's multiplication. Now we're going to split it up with addition, plus log base 3 of x. Whatever your base is in the original problem, that base is going to remain throughout as you do it. If we look at a second example of expanding, if we expand log base 5 of, let's say, 3xy squared over z. Make my parentheses bigger. Okay, here we have a lot of things going on, so we're just going to go piece by piece until we have everything accounted for. I'm going to write down here lower so I have more horizontal space. So we've got log base 5. That's going to repeat the entire time. Log base 5. Inside my parentheses, the first thing I have is 3 times x. We're going to have log base 5 of 3 plus log base 5 of x. Then we have that times y squared. So we're going to have another plus in order to count for the times the y squared, but that squared will come in front of that log. Because it's an exponent, it comes in front. So it'll be plus 2 log base 5 of y. So this 2 came because it was y squared, so that squared comes out in front. The plus came because it was x times y. And then we have divided by. Division splits up into subtraction, so minus is going to send us to the bottom. That's telling us we divided in our original problem. Log base 5 of z. So this is in its expanded form. You'll see the uses of having it in expanded form or having it in condensed form as we go and solve. So there's one more expanded. Let me do a couple where we condense. Okay, so if we have, oops, I need a pen. If we have condense, let's say log of 8 plus log of x minus 3 log y. Now here I didn't write a base. Again, we assume the base is 10. We don't need to fill in that base of 10, just like you don't fill in the 2 on a square root. We don't need to put the base if it's 10. So we want to condense this. We know we're going to have a log, and our base is just going to be 10. It's going to be there. We're going to condense all of this into one set of parentheses. So here we have 8 plus x, so log 8 plus log x. That plus is going to turn into a multiplication, so we'll have 8 times x. So we're going to have an 8x. Here we have a minus. that minus is going to be division inside when we condense. So we're dividing by 3 log y. We also have to remember that this coefficient becomes an exponent. So that's going to be y cubed. So when we put it inside here, the minus will give us our division, and we're dividing by y to the 3rd power. So our condensed form would be the log of 8x over y cubed. We'll do one more. Let's condense. Let me think. We're going to condense 1/3 log base 2 of x plus 2 in parentheses log base 2 of, actually, let's make this a minus. Come here, pen. Minus, so it's going to be a minus 2 log base 2 of y plus log base 2 of z. Okay, so we know our answer is going to be in log base 2. Because I have log base 2's throughout, my answer is going to be in log base 2, and we're going to fill in my parentheses. I see a subtraction here, so I automatically know I'm going to be dividing at some point, so I'm going to go ahead and draw my fraction bar in. So we start with whatever comes first. We've got 1/3 log base 2 of x. That 1/3 is going to become an exponent, so we'll have x to the 1/3 power, which you can't read, so I'll try again. So we have x to the 1/3 power. Then we have minus, which means we're now going to the bottom. So we're going to go down to the bottom. This 2 belongs to all this stuff inside. You could distribute it, but we're condensing, so we're trying not to make more work for ourselves. So this is going to be an exponent for everything inside. So everything in here is going to be squared. So we know whatever was in there, we're going to then square it, because that squared goes to the outside of both of those terms. So we look at what's happening on the inside. We have log base 2 of y plus log base 2 of z. That plus will turn into multiplication of y and z, so we're going to have y, z. So this will be x to the 1/3 over yz squared. The last thing you might encounter, which I'll quickly talk about, is if you run into a problem where you're condensing and you have, let's just go back to simple log of x minus log of y minus log of z. There are a couple different theories on how this works. I like to think that every time you have a minus, that's sending you back down to the bottom. So we're going to condense this to be the log. X is the only positive thing, so it's going to stay up. Minus sends my log y to the bottom. The second minus also sends my log z to the bottom. So it would go down there to the bottom. If by chance you then had another plus sign, so I'm going to go in and change this. So if I change this to plus log z, that plus log z is going to move it back up to the top, because that's a multiplication, that's a positive, so it's going back up to the top, so my z would then be up top. So if you have repeated minuses, each minus goes to the bottom of your fraction. It goes to the denominator. If it goes back to plus, we're going to move that back up to the numerator.